Hi, you already know my name if you already watched my channel, and I am Cordelia. Today we're going to solve the product of primes problem. So before I begin, today's question of the day is why are prime numbers important? Why do I keep doing a question of the day about prime numbers? Okay, anyway, now time to solve the problem. And also before that, remember the answers are at the end of the video. Okay, now time to solve the problem. So, you are given two numbers L and R, and you need to find the product of primes within this range, inclusive. So, if L is a prime number, you include that. If R is a prime number, you include that. If there are no primes in that range, then you must print 1. And also you need to print the product modulo 10 to the power of 9 plus 7. Okay, if the input was L is 1 and R is 10, then the output would have been 210 because 2 times 3 is 6, 6 times 5 is 30, and then 7 times 3 is 21, times 10 is a 210. So all of these times together is 210. For 1 and 20, it's now way bigger. So it's 210 times 11 times 13 times 17 times 19. The constraints are that R is more than L and R is less than 10 to the power of 9, and L minus R is less than 10 to the power of 6. So now time to move on to how I solved it. Also, the time complexity you need is order of R minus L times log of R, and the auxiliary space is order of square root of R. So now time to move on to how I solved it. So I first got this module out, which is math, which just helps a bit with math basically. And I didn't do it just because I love math. Anyway, so here I'm doing the C-Ratterson's function, which I think I already explained in the future in a past video, but I'm just going to cover it again. So I'm setting primes to this. So the primes is 1 if it is prime and 0 if it isn't prime. So basically I'm setting everything to primes at this line, and then on this line we're setting 0 to not prime because it isn't, and then 1 to not prime because 1 has only one divisor, it's itself. Okay, and after that I'm going in a loop through square root of that number where I want to find all the primes too, and then I'm checking if that is 1, then if that's 1, that means it is prime, and if it is, then I'm doing this loop, which is basically, so I'm setting j to I, and I'm doing this loop till j times I is less than n, and then I'm setting primes of I times j to 0, and then I'm adding j to 1 to j, and I'm returning primes at the end. So now time to move on to the only difference of it from the real C-Ratterson's sense. So now here's the actual segmented C part. So I'm setting here j to 1 for I range R to R minus L plus 1. So basically what I'm doing is So it's all the primes from L to R. So the first element in here would be L plus 0, the second would be L plus 1, third would be L plus 2, fourth would be L plus 3, and so on. And then, if L is 1, then I'm setting J of 0 to 0, because 0 plus 1 is 1 and 1 is not prime. And then over here, I'm doing the Sievert-Ratisson's function, which is finding all the primes till the square root of R plus 1. And then over here, I'm looking at what the primes are. So basically, the Sievert function returns 0, returns a list, and the list of 0 if that index is not prime, and it's 1 if that index is prime. So I'm basically getting the index if the item in the array is 1, so I'm getting out the prime numbers, and then I'm iterated through K. Then I'm setting B to math.ceil of L divided by I. So L is the left element, and then I'm dividing it by I, which is the prime number. So basically, if you wanted to find the prime numbers from 90 to 99, then 1 to 9, 2, 3, 5, and 7 are the prime numbers from 1 to 9. And okay, so now 2, and then 90 over 2 is equals to around 45, I think. Yeah, exactly 45. And I'm setting C to max of B and I to handle the cases when when L is 1 and not raise an error. And then I'm doing this loop to go. So if it was 2 times 45 is 90, 2 times 46 is 92, 2 times 47 is 94, 2 times 48 is 96, and 2 times 49 is 98. Okay, so I'm setting that to 0 for every prime number, and I'm adding 1. For every multiple, and I'm adding 1 to C, just so that the loop doesn't end to an infinite loop and keeps on running infinitely. So over here I'm setting NM to 1, and NM is the actual answer I want to print out. Then I'm setting the loop to run from 0 to length of J. And then I'm checking if that element is 1. If it is, then I'm multiplying NM by L plus I. L plus I, because that is a prime number. So 91. Let's get another example. Okay, anyway, so in the end I'm returning NM mod 10 to the power of 9 plus 7, because you know what it says there, print the product mod 10 to the power of 9 plus 7. So that was my code, and as you can see, it is 100% correct. Oh yeah, there's 2 corrects. Okay, anyway, another way to solve this problem would be to take the brute force approach, which is where you're still tempted to use Sievert-Ratisson's. So, fetch all the prime numbers from 1 to L, and then 1 to R, and then after that extract the prime numbers from L to R, and then you have your and then you have your list of prime numbers. Okay, so that was the brute force approach, and the approach I took, which is called segmented sieve. If I didn't already say that, I don't think I did. Okay, anyway, so that was how I solved the problem. Now time for the answer to the question of the day. In case you forgot, the question of the day is why are prime numbers really important? And the answer is, drum roll please, it's because they are used in all kinds of cryptography algorithms, and also an example of an algorithm which uses prime numbers is the RSA algorithm, which takes in two large primes with at least 512 digits, and then after that it combines them together, and then you get the key for the encryption. At least I think that's how. There is another cipher though which works differently. It's called the Venom cipher, and it uses a one-time pad. I'm going to talk about it in a later video. But for now, just to keep it simple, the Venom cipher is the only cipher which has mathematically been proven to be 100% unbreakable. Okay, now that was the answer to the question of the day. So now please like and subscribe my channel, and also ring the bell icon to get more notifications. See you next problem. Bye bye.